All right, this is a check your understanding for topic 2.9. This is we just learned the quotient rule, so we're going to go ahead and try it out. So if f of x equals this function, find f prime of 5. So I'm just going to go ahead and take the derivative straight up. I need f of x first, so f of x is going to equal, f prime of x is going to equal down d up. Sorry, that's going to be my way. Top 2.9, that's good. Okay, so topic, and so doing minus up, d down, all over down squared. Continuing, f prime of x equals 2x squared minus 6x minus, distributing the minus sign and the 1 together, x squared minus 1. So if this makes you uncomfortable distributing from the back on either one, feel free to rearrange its commutative, and you can distribute either direction. Why it doesn't matter, but I've been doing this for a long time, and it used to make me very uncomfortable to distribute from the left, but now I'm good. So just understand that it's okay. So, and then the denominator, which I never FOIL out because if something's going to simplify out, I'll straight cancel. So I don't usually bother. So this makes x squared minus 6x minus 1 for my numerator, all over x minus 3 squared for my denominator. This is f prime of x. So we're still on number 1 here. So I'll probably be using paper for the rest, but that's okay. Now I'm going to go ahead and plug in 5. So I got 5 squared minus 6 times 5 minus 1, and 5 minus 3 squared. So I get 25 minus 30 minus 1 over 2 squared. So I get negative 5 minus negative 6 over 4, which is negative 3 over 2, or negative 1.5. I'm going to check that with my calculator. And so I'm going to go ahead and I'll just do this the other way. So I'm going to do math 8. And I'm going to take the derivative with respect to x. I'm going to go ahead and type my equation in here. And so I get x squared plus 1. Alexa, pause. Dismiss. Alexa, dismiss. Sorry about that. Over x minus 3. Okay, and I'm going to take that derivative with when x is 5. And so remember, I got negative 1.5. Okay, and again, we've got that little bit of error that comes in with the calculator sometimes. So same answer, and I feel pretty comfortable. Good. So I've checked. All right, getting back to our problems, we're going to continue. So again, now my face is away in a different place. That's the joy of having my face on here. All right, so then we're going to do this. I'm going to go ahead and get some paper. Do this problem on. That way I don't have to worry about my face. Not that one. I've written on that. Okay. So I need to find dg dx, which is just the derivative of this, but we're going to go ahead and use their notation. I'm going to change colors. And again, we have down. I'm so sorry about the blurriness of this. Only problem with this camera. Down, D up, minus up, derivative of down, all over down squared. Okay, technically we're finished. We're just going to clean it up a tiny, tiny bit. Actually, we're going to clean it up so that if it was on a circuit or something, we could find it. 4 ln x cosine x minus sine 4 sine x over x all over. But technically, this is the answer, and you can stop right there if it's an open-ended question. But if you're looking for a multiple choice answer or a specific answer, then you go through this process. Okay, I'm going to get the same denominator up here. I'm going to have 4x ln x cosine x minus 4 sine x all over x. So I times this one by x over x, so I could get the same denominator. Okay, and that's all over 4 ln x squared, which becomes 4 ln 4x ln x cosine x minus 4 sine x over x times 1 over 4 ln x squared. Okay, and then x ln x cosine x minus 4 sine x all over x 4x, excuse me. Where did this 4 go? It disappeared. Excuse me for making that disappear. It should be there. Okay, anyway. 4x, excuse me, wrong. X, 4 ln x squared. They might take the denominator and turn it into 16x ln x squared. They probably won't. But anyway, so the denominator, this is a, that's what's correct, but I just didn't rewrite the fraction. So that's all the way. But remember, I was finished right there finding dg dx. So it's just a matter of whether it's an open-ended question or I'm looking for a specific answer question, how much work you have to do. Just kind of keep that in mind. This was not necessary to simplify all the way. I just did. Okay. All right, let's do number 3. So let me write down the answer for number 2 on the paper. dg dx equals 4 ln x cosine x minus 4 sine x over x all over 4 ln x squared. And you could just have the 4x here at the end. I just kind of cleaned that up just a little bit. Or my final answer, which I'm going to leave off because I like this one. It's fine. Just right there. Okay. All right. Let's go ahead and do number 3. Okay, what was up anymore? Just checking. So find h prime. All right, so h prime of x equals down, d up. So this is a hard d up. 6x plus x to the 1/2 will be easier to tell. So there. So since I rewrote that anyway, let me continue in this color. So 1/2 times 2 is 1x minus 1/2. So down, d up minus up. D down, all over, down squared. And again, I'm officially done. But I'm going to go ahead and clean because I like to clean things up. Distributing, I get 6x squared plus x times x to the 1/2. Negative 1/2. So I add my exponents together, and that gives me x to the positive 1/2. right? Okay. So x to the 1/2 minus 3x squared minus 2 square root x over x squared. So I'm going to combine like terms. 6x squared minus 3x squared is 3x squared plus square root x minus 2 square root x over x squared. Again, I'm showing you the work, not me. I could have done this a little faster. 3x squared minus square root x over x squared, and that's where my answer would be. So this one isn't as hard to simplify as the last one was. And I would say it's more likely to be on a multiple choice portion of a test, whereas I would want to see that you didn't simplify. Now we're not going to do a lot of multiple choice while we're in this distance learning environment, but the idea is still here and still valid. Okay, so first times the derivative of the second plus the second times the derivative of the first. This multiplication right there, why x times, that's how I got this number. In case you're wondering where it came from, that's over here. Okay, and there we are. Okay, so I'm going to go ahead and write down the answer for this. H prime of x equals 3x squared radical x. Wait, excuse me, 3x squared minus radical x over x squared. Now sometimes we get really tempted to start canceling things out, but remember you can only cancel it out if it can be factored out of the whole thing, which x squared cannot. All right, number 4. Let q of g of q equal this crazy mess. Find the derivative. Ooh, interesting. M, N, P, and T are all constants. Very, very important sentence. All constants. Okay, which means that the derivatives of these are just them. Okay, so you're looking at this and thinking, oh, do I have to use product? No, that T is some constant value. It doesn't change. The only thing that does change is the Q's. Okay, so let's see what we can do. dg dq, which I'm going to use their writing right there. Before I do that, let me rearrange this. G of q equals 4t. Oh, it's a constant. It's a constant. Since it's a constant, it can go in front of my product. So 4t times down e to the q, b up. So mp times 2q, because remember m and p are just constants, minus n, derivative of q will just be the number in front. Okay, so down, d up minus up, d down, anything e to raise to any power, same thing, all over down squared. Okay, so again, officially done. I'm going to go ahead and do a little simplifying now. So my numerator 4t sits there, fraction, mp 2mp q times e to the q minus n e to the q minus mpq squared times e to the q plus nq e to the q all over e to the q times e to the q, which is e to the 2q. Because power to power, you multiply the powers, or you can think of it this way. If I added them, I'd get 2q. Okay, either one works. And that's all I'm going to do. I'm not going to do much more than that. I think that's good. And again, I was right here. I didn't have to keep going. It is really, really important that they establish these to be constants. One of the things we're going to learn in Unit 3, so not soon, is something called implicit differentiation when you have more than one variable. But we don't this time. Otherwise, if those were all variables, we could not do this problem. Okay? And that's that. One left. And the table below gives these values. Find this. Okay. We need to find h prime of 1. So in order to start, we'll just find h prime of x, which is equal to down, d up, minus up, d down, all over, down squared. Okay, well that seems like it was annoying. So let's go ahead and see what we can do. H of 1. Oh, negative 1, excuse me. So I'm going to go ahead and get g of negative 1 times f of prime of negative 1 minus f of negative 1 times g of negative 1, g prime of negative 1, excuse me, over g of negative 1 squared. So you can see I've just plugged in. That's all I've done here is plug in negative 1 for all the x's. Now I'm going to use my table. So negative 1. G of negative 1 is 3 times f prime of negative 1, which is 5, minus f of negative 1, which is 6, times g prime, which is negative 2, all over g, which was 3 squared. Okay, so I use the top row because all of these are negative 1. I didn't have to do anything fancy, so the other two rows are there to confuse you. Don't let them win. And now here we go. 15 plus 12 over 9, which is equal to 27 over 9, which is equal to 3. So let's do h prime of negative 1 is equal to 3. So these kinds of questions are the ways we ask to see if you know a rule and if you can read the table. So it's kind of a dual thing that we get to practice with on you, and it allows us to make a problem so you can't use photomath and all those things. Okay, so answering this question, h prime of negative 1 was 3. Now with this table, I could also find h prime of 1 and h prime of 3. I can't find any other values because this is all I know. Okay, are there any questions? Well, ask me in class. I'll see you guys soon. Have a great day.